Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll use implicit differentiation to find equation of tangent line. As per the problem, find the equation of tangent to y squared plus 2y plus 10x plus 11 equals 0, which is parallel to 2y plus x equals 0. In this problem, we have to find equation of tangent line to the given curve, and this tangent line is parallel to line 2y plus x equals 0. As you may know, parallel lines have same slope. So the slope of tangent line is equal to slope of the given line 2y plus x equals 0. Let's start by analyzing the equation of the line. We can find the slope of this line by writing it in slope-intercept form, which is y equals mx plus b. For that, we have to isolate y on the left side of the equation. So we should move x to the right side of the equation and it will become negative x. Next, we should divide both sides by 2. I get y equals negative 1 over 2x. In this equation, the coefficient of the x term is negative 1 over 2. So the slope of this given line is negative 1 over 2. This is also the slope of the tangent line. Next, we have to find the value of b, the y-intercept for this tangent line. For that, we have to find a point that lies on the tangent line. As per the problem, the tangent is to the curve y squared plus 2y plus 10x plus 11 equals 0. We can use this equation of the curve to find dy over dx, which represents the slope of tangent to this curve. We can use implicit differentiation to find dy over dx for this equation. We have to find the derivative of all terms in this equation with respect to x. Let's start with the first term y squared. We have to use chain rule because this term has the inner function y and the outer function exponent 2. As per chain rule, we start with the derivative of the outer function. We have to use power rule. We move the exponent 2 to the front of the term and subtract 1 from 2 times the derivative of the inner function y. The derivative of y with respect to x is dy over dx, plus in the second term 2 is the coefficient of the term, so it will stay as it is, and the derivative of y with respect to x is dy over dx. In the third term, 10 is the coefficient of the term, so it will stay as it is, and the derivative of x with respect to x is 1. 11 is a constant, so its derivative is equal to 0. Now we can simplify this equation. Y to the power 1 is just y. We have to isolate dy over dx in this equation. So we should move 10 to the right side of the equation. It will become negative 10. Next, we can factor out dy over dx from both terms on the left side of this equation. Next, we should divide both sides by 2y plus 2. We can simplify this expression by factoring out 2 from the denominator terms. We can reduce 10 and 2. This is the expression for dy over dx. We can use this expression for dy over dx to find a point that lies on the tangent line. We should set this expression for dy over dx equal to the slope of tangent line, which is negative 1 over 2, and solve for y. We should cross multiply the denominators. We should distribute negative 1 into the parentheses. We have to isolate y in this equation. We should move y to the left side of the equation. It will become positive y. And we should move negative 10 to the right side of this equation, and it will become positive 10. I get y equals 9. This is the y-coordinate of the point at which the tangent touches the given curve. We can use this y-coordinate to find the x-coordinate of that point. We should sub in y as 9 in the equation of the curve and solve for x. "99 plus 11 is equal to 110. We can isolate x by moving 110 to the right side of the equation. It will become negative 110. Next, we should divide both sides by 10. I get x equals negative 11. So the point at which the tangent touches the given curve is negative 11, 9. Since this point lies on the tangent line, we can use this point to find the value of b. We should sub in y as 9 and x as negative 11 to find the value of b, the y-intercept of the tangent line. Negative half times negative 11 is positive 11 over 2. We can isolate b in this equation by moving 11 over 2 to the left side of this equation, and it will become negative 11 over 2. The denominator of 9 is 1. We should multiply 9 over 1 by 2 in the numerator and denominator. I get b equals 7 over 2. This is the y-intercept of the tangent line. We can use this value of b to write the equation of the tangent line. Its slope is negative 1 over 2 and y-intercept is 7 over 2. This is the equation of the tangent line in slope-intercept form. This should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.